Assalamualaikum warahmatullahi wabarakatuh and good day. Welcome back to PKS 552 Construction Technology 4. In this video, we're going to continue to learn on the basement construction. There are 6 elements of basement, which are excavation, retaining wall, dewatering system, structural basement wall, structural basement floors, and waterproofing. The first element is excavation. We're going to learn ram system, dam shell and drag line, long arm excavator, and multi-level excavator. For ram system, the slope that will be constructed should be not too steep, which is around 15 degrees to 30 degrees. If you look at dekat photos ni, you nampak ini ram. So ini adalah ram system yang digunakan untuk excavation for basement nak masuk ke bawah ni. Lebar dia kita mesti make sure that both excavator and transporters able to freely move within the basement ram yang kita dah construct tu lah. However, the problem is in wet or raining, lorries cannot move in and out of the basement because of akan terbenam because of heavy load from lorries tu. Next, we have dam shell and drag line. For dam shell, it is to excavate the area near the ram. Jadi sebab dam shell ni dia panjang jadi mostly digunakan untuk mining sector, tapi kalau untuk construction of basement pun boleh juga sebab dia tinggi, jadi dia boleh excavate, dia boleh panjang melangkau untuk excavate. Depan dam shell tu dia macam ada clamp so dia akan kepit tanah dan angkat. For drag line, a machine yang ada tali dan dia akan transport the soil yang dia ambil dia kumpul tu, okay, and then dia akan transport. Lorry waiting at the ground level, tak perlulah lorry tu nak turun bawah because this drag line ni yang akan transport the soil ke lorry tu. It can reach to 10 meter and go maximum depth as 9 meter deep. Next we have a long arm excavator. It can reach 18.5 meter and the maximum depth is 15 meter. If more than one machine that is being used, the total depth and the total length can also be increased. And if in shallow or small size basement, the use of this long arm excavator is not economical sebab idling time dia lebih lama sebab mesin ni tak diguna pakai to the maximum sebab dia lebih idle. Kita tak dapat menggunakan the full capacity of the machine. Last, kita ada multi-level excavator. It is similar to passing baton concept which requires several excavating machine located along the ram and lorries waiting at the grid level. See dekat sini dia ada ram dia akan excavate, this one excavator ni akan excavate dekat sini and then dia akan pass here and this excavator akan pick up the salt and letak dekat dalam lori, so passing the baton. This is the example of the drag line kalau you nampak kat sini dia ada macam bucket, so bucket ni lah yang akan fill with the spoils yang akan being removed. Jadi dia akan bawa these spoils and then remove daripada side, and this is the long arm excavator. The second element of basement is retaining wall. So retaining wall we have temporary and permanent. For temporary, we're going to learn the solder pile with timber boarding and steel sheet piling, which is kita dah familiar, kita dah pernah tengok before this. And for permanent retaining wall, we're going to look at the diaphragm wall, contiguous pole pile, and second pile. Solder pile is a very old and traditional method of constructing a retaining wall. It is commonly used in the site of less problem or constructing basement in highland site where groundwater is not a problem. Maksudnya tak ada groundwater yang akan affect the retaining wall, yang akan penetrate through the wall. Jadi kita boleh pakai this type of temporary retaining wall masa tengah construction. Dan biasanya dekat solder pile ni, depan dia ni dia akan pasang this timber boarding as you see here So ini solder pile and then ada timber boarding. For solder pile, it is normally H steel pile. It is about 12 meter in length. Dia akan driven at predetermined space. Timber boarding or leggings, maksudnya timber board lah, yang sizingnya lebih kurang macam ni, are inserted during the excavation. Joints between timber leggings are usually not watertight and the main function is only to hold earth. That's why we must make sure that area yang kita excavate tu tak ada groundwater yang berada dekat dalam tanah. Ground anchors are used to hold the solder piles. Usually akan ada this ground anchor. Tanah yang nak ditahan tu akan di-anchor lah, as what you learn dalam topik sebelum ni. This is the cross section of the solder pile. As you can see dekat elevation view, solder piles ni in between usually akan ada strutting. And ini adalah timber legging tadi. Strutting ni nak avoid daripada collapse lah. And from plan view, as you can see, ini solder piles bentuk H. So kat sini ada timber legging. And ini adalah strut ataupun anchor itulah yang akan anchor pada dalam tanah. Steel sheet pile is most suitable for shallow and depth of basement around 12 meter height. So as to avoid jointing in sheet piling vertically. Maksud saya sebab sheet piling ni selalunya dia akan datang dalam 12 meter. So kalau kita ada basement yang lebih dalam daripada that 12 meter, then we need to do vertical jointing. Okay, so sheet piling mungkin akan diletak kat atas ni. And because you want to avoid that, limitkan ke 12 meter. For very high situation where tendency to fail, it is needed to use bracing. For any incorrect alignment will lead to water ingress. It is required the use of interlocking sheet pile untuk avoid water penetration. Sebab kita tak nak air daripada tanah tu masuk ke dalam our basement masa tengah construction. To install sheet piling, we can do pile driving. One is by vibrating, which is better verticality. And another one is hammer. Okay, but it is bad for verticality and possibility of misaligned because no space for pile head to receive hammering. For steel sheet pile, it is also suitable for site where the space around the excavation is insufficient for sloping back the sides. It is usually necessary to provide lateral support at one or two more levels above the ground. That can be done using two ways, that is, one is internal braces ataupun pakai tie-back anchor. Kita boleh juga provide lateral support so that kita nak avoid daripada the collapse. Kita pakai internal brace ataupun tie-back anchor. This is the type of sheet pile, which is one is standard straight and then standard shallow arch, standard deep arch. Steel sheet pile boleh juga kita guna kat dalam air like this one. Because it is a temporary retaining wall kan, so kita akan buat this steel sheet piles dekat area yang kita nak excavate. If we want to do any works inside kan, so kita boleh pump out the water so that the water will be removed around our working area. That is another possible purpose of steel sheet piling. The first permanent retaining wall is diaphragm wall. The technique of building auxiliary walls involve the casting of concrete. Jadi kena bina dulu concrete walls yang ketebalannya 450 mm ke 1.5 meter dan ketinggian kedalaman dia adalah sampai 122 meter. Below grade around one or more side of the excavation. Jadi around the excavation site tu Diaphragm walls are commonly used in clay and sand with gravel areas. The resulting wall is substantially watertight. Tak ada penetration daripada air. First, a guide trench is excavated and lined with lightly reinforced concrete. Guide wall ni act as guideline for the excavating machineries. Jadi dia akan, for example, kalau kita nak dia straight, so dia akan straight je because of ada this guide wall. which you can see here. Ni dua ni adalah guide wall yang warna kuning tu. It provides reservoir for the slurry and it will enable paving and underground services to be broken out ahead of the excavation. As excavation proceeds, the site are prevented from falling in by keeping the excavated area filled with bentonite slurry. Bentonite slurry ni biasanya kita pakai untuk any trench excavation ataupun untuk basement construction juga. It is to stabilize excavation because nanti kalau tanah tu kita letak dengan bentonite slurry, nanti tanah tu dia akan jadi macam gel-like. Bentuk dia macam gel lah, dia akan jadi macam gel. So dia akan melekatkan tanah tu to each other. The methods of excavation vary with the special contractor in the question, but usually involve clamshell grabs, which look like this, rotating wheel cutters or other means. So rotating wheel cutters tu dia bulat but dia ada macam like macam potong tu lah. I pun don't know how to draw, but something like that. As excavation proceeds, so it is kept full with the bentonite liquid and the excavation carried out in base, which means this is actually one segment. Okay, segment juga lagi. Jadi dia sebelah dia ni dia tinggalkan lagi, kita tak buat dulu, kita tak akan excavate dulu sebelah dia ni. Kita akan excavate dia alternate macam ni. Alternate configuration of the base is usually adopted unless the engineer require wider spacing to maintain the stability of the adjoining boundaries. The diaphragm wall is constructed in alternate panels around 5 meter long. So normally this is like 5 meter long. During excavation, the above alternating approach give both edges of the proposed to be excavated panel with hard dry surfaces. Therefore, bila sini dah dikonstruk dan later on kita akan construct dekat sebelah dia juga. Sebelah dia. Okay, later after the one yang the segment yang kita buat tu, yang alternate tu siap dulu. Once a bay has been excavated, prefabricated reinforcement is lowered into the excavated area. Setiap excavation, reinforcement dimasukkanlah, displacing some of the soil. The surplus liquid is pumped back to the storage tank. Liquid tu maksudnya bentonite slurry. Concrete is now poured into the trench by means of tremie. The hydrophrase machine is used to cut an interlocking surface into a previously cast segment of wall. Interlocking precast concrete section can also be used. The hydrophrase machine is used to cut an interlocking surface into the previously cast segment of the wall. Interlocking precast concrete section can also be used. So hydrophrase machine is quite big machine. So in between wall yang being casted here, you nak remove the soil around here, we can use the hydrophrase machine. So dia ada cutter and kita akan pump out keluar the soil so that we can construct diaphragm wall dekat that area. However, interlocking precast concrete section also boleh digunakan untuk area yang ini. Once the precast concrete section are in place, grout is used to fill the remaining joints. So joint between ni akan diisi dengan grout. Ataupun joint between each section, maksudnya section yang bersebelahan tu boleh juga kita cast using steel tube ataupun interlocking junction ataupun hexagonal sheet piles to reduce the ingress of water through the joint, to make sure that the joint is firm atau is sturdy. Maksudnya joints tu memang takkan ada celahan-celah yang boleh masuk air. This is the example kalau diaphragm wall using tube techniques. Kat sini in between walls ni letak pakai tube lah, and then fill in dengan concrete inside, and then the joints between wall tu akan lebih kukuh lah. And this is the example if we use precast wall with interlocking joint. This is the hydrophrase machine. Nampak kat bawah ni ada these two rotating, dia macam cutter, so dia akan cut all the soil dekat bawah tu, and actually dia punya ukuran tu dah cun-cun lah ikut our panel tu besar mana, and they works very fast this hydrophrase machine. This is the sequence kalau kita nak excavate. After that kita nak build the diaphragm wall untuk satu section saja, satu bay saja. Excavate at one side here, pakai clamshell this one, and then dekat sini, and then baru dia remove kan dekat tengah ni pula. Okay, so dah ada hole dekat sini, and then baru masukkan reinforcement, then pipe down the concrete, then siaplah the diaphragm wall untuk satu bay. There are many advantages of diaphragm wall, such as installation is free from vibration and excessive noise. Walls are constructed with minimum disruption to adjacent area, because one thing we know that our machineries that we use pakai clamshell, pakai this hydrophase machine, it doesn't produce any vibration ataupun bunyi yang sangat bising so the adjacent structure also tak ada vibration, so adjacent structure kuranglah kerosakan dia. This wall form a dual purpose. They avoid the need for temporary sheeting to the excavation, and they become the final structure wall of or the permanent works. Therefore, kita tak perlu guna solder pile ataupun sheet pile for temporary work. So, terus buat diaphragm wall, dan diaphragm wall ni pun bila dah siap boleh terus jadi the actual wall. Diaphragm wall are substantially watertight. Diaphragm walls need support, and this may be provided by permanent structure within the basement or by ground anchor acting outside the wall. Therefore, kita kenalah letak, for example, anchor lah kat belakang, tie back, something like that, ataupun mesti ada permanent structure dekat depan, contohnya wall lain lah kat depan. However, diaphragm wall also have disadvantages, such as possibility of slight seepage of water or dampness to the joint. We must remember that the construction is in situ. Jadi bila in situ ni, we cannot make sure that whatever yang constructed down below, the concrete betul-betul kering, okay, and then tak ada any exposure of reinforcement terkeluar and whatnot. Jadi bila dia in situ, we don't know what happened down there. Concrete is poured in a continuous operation. Jadi sentiasa je concrete ni kena pour So as I said, bila dia sentiasa di-pour kat bawah tu, we don't know what happened. Contiguous bore pile or CBP. A ring beam is cast along the top of the piles, linking all the piles together. This provides extra rigidity and strength and help to distribute any load placed on top of the pile. This is the ring beam. Ground anchor can also be used to help resisting the overturning forces caused by surrounding strata and hydrostatic pressure. Mungkin dari air dekat belah belakang CBP ni The typical sequence of construction is such that the next pile is to be constructed more than 3 meters away from the previous one. So if you see kat sini, dia ada phase 1 which is here, here and here. On the next phase, construct pula CBP dekat sebelah yang the first phase tadi. That's why in between this one, dia lebih dari 3 meter atau lebih lah. Sebab nak make room untuk another CBP untuk duduk dekat in between the first phase piling tadi. Contiguous piling may be covered with mesh reinforcement or fabric, faced with the rendering or sprayed concrete or shotcreting or igniting. CBP ni last kali kita akan shotcrete lah, as in the high pressure spray of concreting ataupun mortar. Ground is normally forced in through the anchor to tie it securely into the ground, while the area surrounding the retaining structure accommodate roots, structure or other property. Ground may be forced into the ground to produce a positive pressure on the ground, which counteracts the possibility of settlement caused by the excavation of the basement and movement of the retaining walls. Sebab ada loading and such. The excavation of basement may cause settlement due to the vibration, which caused by the surrounding ground to compact. Also, the surrounding ground applies its load to the retaining wall. Some slight movement will occur sebab ada juga loading yang akan transfer, jadi ada movement. Vibration and movement of the retaining wall will result in settlement of the surrounding ground. The pressure exerted by pressurized grout can be used to remove the potential settlement. Another thing, because of soil dia ada cavity, ground tu dia ada cavity in between, jadi this grout will fill in those cavities. As what in the illustration, this is how the CBP look like. So ini adalah that ring beam tu. All this CBP ni untuk distribute load This is how contiguous pile wall look like So in between ni ada spacing, kalau you nampak lah ada spacing between the piling. So nampak sangat, memang obvious dekat situ. For the construction process of the CBP, each pile is made by screwing an auger into the ground. The auger, called a continuous flight auger, has a hollow stem in the middle of a continuous spiral drill. Jadi akan drill lah masuk auger ni ke dalam tanah to create lubang Once the drill has reached the required depth below the ground, high slump concrete is pumped down the hollow stem of the auger to the bottom of the bore. So dalam tengah-tengah auger tu ada lubang yang kita boleh guna macam masukkan pipe dekat dalam that auger untuk pump out concrete ke dalam hole. Once the pumping start, the auger is progressively withdrawn. The withdrawing auger brings the soil from the bore to the surface. Dia akan bawa, sebab dia kan macam auger, dia berpusing. Jadi pusingan dia tu akan bawa naik tanah ke atas. Thus, the side of the bore are supported at all times by the soil-filled auger or concrete. So that's why masa auger tu dekat bawah lagi, kita dah start pump concrete. So that auger tu berada dekat dalam auger tu boleh hold the side of the hole tu supaya tanah-tanah dekat hole tu tak collapse Immediately the entire bore has been concreted, barulah reinforcement cage is lowered into the concrete filled bore. Second, piles. Used in dry earth situation where no water to penetrate. Kita tak nak ada water langsung yang penetrate. To retain earth as well as water penetration. So this second piles memang avoid water daripada penetrate masuk ke dalam our basement betul-betul Used in the situation where water is the major problem. Exposed surface of the second pile can be faced with a reinforced rendering ataupun covered with mesh reinforcement as sprayed with concrete, which is shotcrete or skin walls, whether it is a reinforced concrete wall ataupun brick wall. Pasanglah another wall dekat depan that second pile. Sebenarnya CBP pun orang buat macam tu juga Orang akan pakai this kind of cover untuk tutup the CBP juga. A major shortcoming of contiguous bore pile is the gap between piles and the consequent lack of water resistance of the excavation support. This problem is overcome by the use of modified version, which we call it as second piles. It consists two sets of interlocking contiguous piles. So actually sama lebih kurang macam contiguous pile, it's just that ada pile yang bersambung berdekatan sambung. Sebab kalau kita tengok CBP, pile dia ada jarak in between. Okay, sebelah sini. Jadi dia ada gap kat sini in between tu. Jadi this second pile adalah modified version, a better version of CBP. The first one is a primary, it is soft, and the secondary one is hard. Piles are interlocked with each other. The primary piles are the first constructed in an alternate manner to leave a clear space for the construction of the secondary piles later. The primary piles are cast with a specified strength of mass concrete, usually lower strength concrete without reinforcement. That's why kita panggil dia soft used as water retaining structure rather than a load-bearing wall. The boring of secondary piles is done before the concrete in the primary piles has gained full strength. Okay, that's why kita boleh buat masa dia tengah soft lagi to reduce wear on the blades of the auger. The secondary piles are concreted and reinforced in the same way as the CBP. So this is the secondary piles. Only the secondary piles are reinforced. Ini one option. The unreinforced primary piles provide water resistant layer between the secondary piles, where greater bending strength of the support system is required. Okay, kalau perlu, then there is another method, which is the primary piles are also reinforced. This is the primary. Generally with a wide flange steel section. Contohnya kita boleh pakai H piles. And the secondary piles are reinforced with a circular steel reinforcement cage. When the second wall is in place, the excavated face can be covered with a layer of structural concrete. The concrete can either spray or cast against the wall, providing a fair face concrete finish. So basically bila second wall pile ni dah siap tapi dia punya surface tu not very nice looking kan. So kita boleh buat finishes. For example, kita boleh spray dengan shotcrete or kita boleh provide another wall lah in front of the second wall ni. A reinforced concrete ring beam connects all the pile together, improving the structural stability of the wall. The beam will also help to distribute any load placed on top of the wall. Therefore, this one is similar with the CBP. Ada ring beam on the top of the pile untuk load distribution dengan improve stability of the wall. The depth of the wall is usually limited to 25 meter. However, it is possible to construct wall to a depth of 55 meter. Multi-story basements are usually stabilized by ground anchors and cross-bracing to resist lateral forces. So, multi-story basement ni kita boleh stabilizekan dia whether kita pakai ground anchors, as in dekat belakang of that second wall piles tu kita buat ground anchors yang macam you pernah belajar dalam soil stabilization chapter, or maybe kita boleh pasang cross bracing. Maksudnya cross bracing tu memang dekat dalam dekat dalam basement tu ada cross bracing tapi kita tak nampak lah, it is hidden mungkin dekat atas, bahagian atas it is hidden, there is a bracing. So ini illustration of the second wall pile, similar like the previous second wall piles again with the ring beam. Next, we're going to look at the construction process of second piles. The construction process is almost similar as CBP. First, we need to construct the guide wall. Next, we're going to insert the casing, using a vibro hammer. Next, we're going to auger the ground. So, ground ni akan kita drill and remove the soil daripada the hole. Next, concreting of the primary borehole using a tremie, and casing masih lagi ada kat dalam. Okay, this is to maintain supaya ground tu tak bergerak, tak runtuh. So dia ada support for the ground. Step 2 dengan step 4 actually dah di repeat supaya kita dapat construct another primary second pile. Okay, this one sebab dia kan alternate kan, in between of that primary tu akan ada secondary, so dekat tengah ni ada secondary, and kita buat lagi augering untuk secondary borehole, maksudnya secondary second pile. Tapi masa kita auger ni kita must make sure that yang primary 2 ni yang duduk dekat sini dia tak reach lagi dia punya maximum strength, tak rosak lah this auger Jadi memang dia overlap. For secondary second pile, there is a reinforcement, so we must put the steel cage inside. Next, we concrete the secondary borehole. The process will be repeated for the next primary second pile, and then kita construct lagi the secondary, and then construct the primary, construct the secondary. So sebenarnya bila kita construct ni bukanlah only one auger yang akan buat, akan ada a few yang bergerak sama-sama to construct a few of the second pile so that dia boleh berjalan sama. The third element of basement is dewatering system, such as sump pumping, well point system, shallow or deep bore wells, and horizontal groundwater control. Dewatering system is part of groundwater control system. The function is to exclude the water from a particular area and lower the water table. Sump pumping. Some of water collection pit should be excavated below the formation level of excavation, preferably sited in a corner position to reduce any possible soil movement due to settlement. Sump pumping can be very effective and economic method. The technique can work well in well-graded coarse soils or in hard fissured rock. However, inability can occur in fine-grained soil, for example silts and fine sand, where fine particles can drawn out of the soil, resulting in ground movement and settlement. Open sump pumping is usually limited to maximum depth of 7.5 meter due to the limitation of the suction lift of pumps. Each pump is equipped with robust pump with a capacity to handle some solids, well-graded coarse soil ataupun gravelly sand, sandy gravel. So mostly is the gravels lah. So silts ni dia very small particles, nanti dia akan masuk dalam pump. And what happen to your basement, jadi akan ada cavity in between. So akan ada settlement pada the basement. Disposal of water from sump pumping can also create problems because pump water may have a high sediment load which can cause environmental problems at a disposal point. Alternative method to sump pumping is jetted pump. So as you see daripada the illustration, this is the excavation area. So ini adalah area basement. The sump pump is located normally dekat corner dekat tepi-tepi. So kita tak nak dia, satu tak nak banyak settlement. And another thing, dia akan mengganggu lah. Sump pumping dia akan letak ke bawah. Air ni semua akan dipump out, keluar. So ini semua adalah air daripada groundwater. So kita nak keluarkan air daripada dalam tanah. So inilah dia. So collector drain ni maybe macam air daripada hujan and whatnot akan bawa ke sini. And then ni sump kita. Sump pump ni akan pump out. Okay, so keluar lah. And then ini adalah discharge pipe work. So all the water yang coming daripada bawah ni akan naik ke atas dan kita akan collect and bawa keluar lah, okay, to the discharge pipe work. This is the detailed cross section. This is the example. Some pit provided inside the lowest level of basement to collect water and remove by pump. Basically daripada bawah ni. Kita dah tak nampak lah sebab dia daripada bawah dah tertutup. Well point system. This is the popular method for water lowering in non-cohesive soil up to depth of 5 to 6 meter. To dewater beyond above depth required a multi-stage installation. 2 meter below, 3 meter below, whatnot. So ini sesuai untuk 5 to 6 meter. Tapi kalau lebih dari itu, we need to dewater groundwater, then kita boleh buat multi-stage installation. Water jet into the ground a number of small diameter wells which are connected to a header pipe which is attached to a vacuum pump. Actually, around this area, kalau you nampak, ini semua adalah well. Tapi kecil je lah, small diameter well. Collect water lah daripada this well untuk pump it out. This how it works. This well point, we have a lot keliling tu. So dia ada filter, so dia akan tarik water masuk ke dalam. This is the actual groundwater table. Well ni akan collect water lah yang ada dekat dalam ground ni. Okay, dia akan masuk. Okay, pergi pada well point pumps and then kita akan discharge. Well point system can be installed with the header pipe. Ni adalah header pipe yang connectkan well point ni. So dia akan collect water from there. A ring main enclosing the area to be excavated with one operation pump and another standby pump. This is operation pump and then kita ada standby pump. A progressive line arrangement where the header pipe is placed alongside a trench or similar excavation to the side or both sides. Well point system is a more effective method of ensuring the water is removed from the area of the excavation during the period of the work. It requires a small device yang kita panggil the well point. Okay, this is called jetting. Sebab kita force well point ni untuk masuk ke dalam ground. So ini adalah another method which is more effective than the previous method, which is sump pump tadi. The well point are jetted into the ground around the proposed excavation down to the depth of 5 to 6 meter, which is the maximum for single well point system. The well point are placed about every 1.5 meter, jarak dia untuk setiap satu tu, and are linked together by a ring main connected to a pump. And this is how it works. As the well point is jetted in, length of pipe are attached to it until the required depth is reached. When the suction pump is started, jadi inilah suction pump yang akan tarik keluar. Water is drawn through the well point which are screened out fine material. So dia akan screen out lah. Dia takkan masukkan sekali dalam the discharge pipe. The pump must kept running continuously to keep water out of the excavation throughout the work. To increase the depth of dewatering, a two-stage installation can be employed. Kalau ada lagi nak masuk ke dalam, so you have to build another slope and do it below here lah. So ada lagi two stage, another stage below. Shallow bore wells, similar to well point pumping, but is more appropriate when the earlier method is to be operated for longer period. Thus, running costs are less. Kalau longer period maksudnya masa kita tengah membuat groundworks tu, kita guna sistem well point dia lebih economic. If not, then we can use these shallow bore wells. It can be arranged as multi-stage system when depth exceed 5 meter. That's why dia sama, almost sama macam well point pumping. Another similar system as the well point is deep bore wells. However, this one lebih dalam when depth greater than 9 meter. A borehole is formed by sinking a 300 to 600 mm diameter steel lining tube into the ground to a required depth. Akan ada well point system, tapi sistem ni kita akan bore dia lebih dalam with the help of steel lining tube. A perforated well liner to be installed with the electro-submersible pump to extract water is lowered. So kat bawah ni pun ada pump juga. Okay, sebab dia dah ke dalam submersible pump. This pump akan attract the waters untuk masuk ke dalam, tarik dia. The annular space is filled with a suitable media such as sand and gravel as the outer lining tube is removed. Horizontal groundwater control, consisting of installing into the ground 100 mm diameter PVC suction pipe. The difference dengan yang previous, semua yang lain adalah vertical. Pipe ni adalah letaknya horizontal, so dia akan suck into it like this. The pipe is covered with a nylon filter sleeve to prevent the infiltration of fine particles. So sebenarnya dalam pipe tu ada lubang-lubang dekat pipe tu, so tapi dia kena covered dengan nylon filters lah, so that fine particles tak masuk dalam lubang-lubang yang ada dekat pipe tu. The pipe is then connected to a single suction pipe. It can handle approximately 230 meter of pipe run. However, kalau pumping length, maksudnya the pipe tu lebih panjang, excess, an overlap of consecutive pipe length is up to 4 meter is required. The fourth basement element, basement wall. Waterproofing tanking on the outer surface plus skin walls to cover and protect the tanking using the asphalt tanking yang kita akan tengok next. Wall panels are protected horizontally and vertically from the penetration of water with the aid of water stop. The fifth element of basement, basement floor. Thickness of basement floor will depend on the soil condition, in particular the water pressure from below. There is two situations where a floor with pile caps and piles and a floor without pile caps only use shallow foundation, which is rough foundation. The main problems that happen in basement wall and floor is the jointing system, because there are too many joints as a result of large amount of concrete in basement. Bila ada banyak sangat elemen yang kita gunakan, akan ada banyak jointing. And when there is more jointing, there is more possibility of water to ingress, untuk masuk. And to overcome this, we need to use water stop or apply bitumen or waterproof concrete. The sixth element of basement is waterproofing. The waterproofing is used to waterproof the area for the wall and the floor for the basement. It is in the form of liquid application and laying of pieces and sheets. The asphalt tanking is provided as a physical barrier forming a tanking system using either sheet membranes ataupun liquid ataupun kedua-duanya. Sheet membranes are preformed factory-made in rolls which are bonded or cast against the substrate to form a continuous membrane by lapping. Jadi dia akan overlap each other. Lapping may be achieved by torching or flaming, use bonding compound or self-adhesive membrane. Liquid membranes come in either one or two components of liquid or gel form. They are applied either by brush, roller ataupun spray. Liquid membranes give the flexibility for works on uneven surface and complicated details. This method is costly but durable. Applied and spread hot in 3 coats to a thickness of 20 mm for vertical and 30 mm for horizontal work. This is for liquid asphalt. Joints between each layer of asphalt in each coat should be staggered at least 75 mm for vertical and 150 mm for horizontal work with the joint in succeeding coats. Asphalt should be applied to the outside face of structural walls and under structural floor so that the walls and floor provide resistance against water pressure on the asphalt and the asphalt keeps water from the basement. As you can see in the illustration, bottom here kita ada letak juga asphalt coating and here also we put it same with the wall and up here also ada asphalt. This is the example of the asphalt used in the basement construction. This one adalah sheet type asphalt. And this one, if you see, ini adalah jenis liquid. And normally for this one pun kita akan pakai for liquid type And ini adalah membrane dia, jenis sheets lah. Concrete admixture. Integral waterproofing includes cementitious plaster or crystalline admixture for concrete or mortar that reacts chemically to stop up pores of these materials and render them watertight. So sebenarnya ini adalah konkrit yang kita mixkan dengan admixture. Ability untuk protect against the water. It may be applied to the surface of existing concrete or masonry or use an admixture in a new concrete. Unlike most other waterproofing materials, many integral waterproofing materials can be applied as negative side waterproofing. That is applied to the inner side of the concrete walls, acting to resist water passage from the opposite side, di belah dalam, bukan dekat area luar. Maksudnya bukan dekat area yang jumpa dengan ground tu, dia di belah dalam lah. Drain cavity system. In the form of plastic rolls, water will flow down the rolls through the drain pipe straight to the sump for discharging. This method is not suitable in condition of high water pressure or high water tables. Cavity drain structure make allowance for a small amount of water that may pass through the external walls. The basement is constructed with 2 walls forming a void between the external and internal leaf, and a cavity is formed in the walls around the basement and below the floor. Traditionally, cavities were formed with floor tiles, which created a void and 2 separate leaves of masonry walling. Nowadays, rolls of studded 1 mm thick polyethylene are used with raised stud domes which stand between 5 and 20 mm from the surface. Sebenarnya rolls ni ataupun dia macam membrane lah, polyethylene ni, dia ada studs yang ternaik tu stand between 5 and 20 mm from the surface. Itu rupa dia. The sheet of polyethylene which come in roll 20 mm long by 1.4 meter wide are applied to structural walls and floors to form a very small but effective void. Jadi daripada studs ni kan ada boleh laluan, macam ada area yang tak ada studs tu, so area tu boleh jadi laluan air. The sheets are fixed to the wall using the effective plug and screw system and then permanently held and protected by concrete screed or in situ concrete walls. Any water that penetrates to the external wall or floor is guided to the drainage channel where it is then pumped out of the building. Jadi, for example here in this picture, as you can see, ini ada second pile. This drain cavity system, this sheet kita pasang dekat di second pile, lepas tu nanti dekat depan ni kita pasang lah wall. Tapi kita takkan nampak lah air tu bergerak because the finishes ada wall, tapi belah dalam mungkin ada air yang bergerak, dia akan lalu through this cavity and go to the drain and then akan dia pump out keluar daripada building. Same goes with the floor. This is the sheet and kat sini ada floor finishes. For example, cement screed. If the water flow is expected to be relatively high, a sealed cavity system is used. All the water that penetrates the wall flows under gravity to the sump pit where it is then pumped away. In existing building where the walls of basement are damp and not subject to water flow, a ventilated cavity system may be used. There are a few other systems. The cavity helps to keep the damp surface away from the internal walls and wall finishes. Moisture on the internal walls of the wall will be evaporated and the ventilation system guide the moist air out of the structure. This is the cross-section of the drain cavity system. As you can see, there is a cavity well membrane. Ni membrane, kat bawah ni pun ada membrane. And kat sini ada some pump system which akan pump out the water from the building. This is achieved by constructing an inner non-load bearing wall to create a cavity and special precast concrete drainage tiles over the basement floor, but below the actual floor tile finishes, screeds and DPM. Therefore, you takkan nampak. Once the basement dah dibuat, you takkan nampak all the system from the inside, daripada dalam basement tu you takkan nampak. We have reached the end of this recorded video. Thank you for your attention. I will end the recorded video with the quote from Sukarno, the first president of Indonesia. Gantungkan cita-citamu setinggi langit. Bermimpilah setinggi langit. Jika engkau jatuh, engkau akan jatuh di antara bintang-bintang.